I'm going to go back to my roots for a few days this next week. I got these 10 Blakes in from a customer. He doesn't have a machine, and so I'm going to do some custom bevel grinds on there. I'm going to show off the capabilities of the machine and also of the Multi-Guide Pro. So I'll video that as I work through these. 4 of these are going to be Scandi. 2 of them will be regular flat grind, and then these will be, I believe, full height flat grinds, or maybe an inch high. I'll have to check this paper and remind myself what it is. And then they'll each get a surface grind, surface finished. So got that to look forward to, and I haven't ground in a while, so it'll be nice to get my hands back on knives. I already set up my guide, squared it up. I like to start out from a known position. I really don't know any other way to do that effectively, or to set up your machine effectively. Then you get to a known point, and then you work from there. So I've squared everything. I'm squared up this way. I'm squared up that way. I'm squared across the face. I'm squared in that way. I've squared these up already to across the face. And so now what I can do, what I will do from this point on is I can I'll use the rotation, tilting of the Platen to set my bevel angle. And I've got the calculations from the bevel calculator that's online. This one is going to be 1.5 inches wide by a thickness of 0.165 thickness, and it's going to go to a full flat grind. So I will set that one at 2.9 degrees. I do that by using this Wixie. I put that on the back, I zero it, and then I loosen the handle and go from 0, I will move 2.9 degrees. And that's how I personally set it up. The bevel guide also, if you have a fixed Platen and you're unable to rotate your Platen, the bevel guide's mount has a swivel down here, so you can do that as well. For me, I'm just going to move the Platen, and then on this other knife, this one's already set up. I messed with it a little bit. This is going to be, this one's 1.25 inches width or height, and then it's the same 0.165 thickness. The customer on this asked for something different, so it's going to have all of his knives he wanted at 0.015 edge thickness. So the Scandi is going to go up a half an inch and then end with 0.015. And so the 0.015 is going to be 8.6 degrees. So it'll go up a half inch high and then hit the leave 0.015 at the center, and that's what the 8.6 degrees will do. And then this same style of blank, So this one is going to be a full flat grind, 1.25 inch wide, same thickness. That one will take a 3.4 degree setting to go all the way up and leave a 15 thousandths along the cutting edge. So that's what the project is. I got 10 of those. I'm going to use them to showcase the machine and the bevel guide. Bevel guide's been selling for several years now. The machine is something new that I built in response to customers. After they were using the bevel guide, they were finding that their machines, they wish their machines were a lot more powerful and a lot faster. And so I made one that's more powerful and faster. You can see that I messed with this one a little bit, and it's starting out pretty good. The reason I just did this one as a test grind, these some of these blanks came in from the customer. They had bows in them from his heat treater. This one has a bow in it. The bow is going like this on this top blank, and so you can see that demonstrated, or you can see that manifest here as the bow pulls away from the belt. The grind doesn't go as high, and as it springs out, it widens the grind a little bit up here on this end. And of course that'll be opposite on the other side, because it's going to bow in. It's going to, it's going to bow in like this. So the high spot will be down here and the low spot will be up in there. So I'll work on that. The others have some bends. They're not quite as exaggerated as this one. So I just did that a little bit to kind of demonstrate to him what we'd be dealing with. I'm going to reset this back up. I had it set up, and then I did that little test grind and took it apart. So what I'm going to do here, let me get this out a little ways. Right about there. I'm going to set that blank in there. Set that blank in there up against that, and then I'll slide this in here. This isn't super critical where this goes. It does need to stick out some. This one I'm going to set on top of that plate and up against the other one. That way this other knife has some clearance. And then I will put this on. And because of that bow in there, I'm not going to put it as fully tight as I might. I'm going to allow some room for that bow to go through the angles without fighting me a lot. So I'm going to press on there a little bit. Alright, snug that down. Alright, so that's going to allow me free movement through there without fighting a lot. Do this one here. This one's a little snugger because it's bowing out, but the guide pinches it together and holds it together some. Okay. Then I already have the bevel stop set up on there. I've got a little bevel target line here. I'm about I'm about a tenth of an inch away to the side, that side. I'll creep that back in to about 1/16 of an inch of the bevel line, and then I will grind the bevel. And then on a final step, I will move everything in. I've got my guide set up. I added a second one that will allow me to shift this direction. And then I will shift everything over using this adjustment knob until I hit where I want. And then at that point, I will go in and just do a final grind of just this area here. I've found over the years of using the guide that trying to grind the bevel and all the way up to the plunge line in the same operation just isn't effective. Things will jump. You hit the edge of the belt and all of a sudden it will pull over quickly and grind past there, so I give it some room and then do that as a final separate operation. And I'll demonstrate that when it comes time. Well, first off, I'm going to set up for one of these. I'm going to set up and do these four big blanks that are 1.5 inches wide. I'm going to set those up. So I'm going to run the bevel guide up to, or run the Platen back to 2.9 degrees, and the guide is already set up for these as well. I mean, I run them 2 at a time, so it's set up for those. They're all the same thickness. All 10 of them are the same, which was nice. So I just leave that the same thickness. And then what happens here is this inner one rides on that little piece of shelf that sticks out there, and that controls the depth that the blank getting cut will go in against the belt, so that you don't have to worry about over penetrating and sticking your blank down below into there, the cutting area. And that's what, that shelf is what gives this real clean line, because you have a positive control all the way across there, and it gives a really clean line, clean and even all the way across there when you do it right. And it's really quick and easy to do that. So I'll be demonstrating that as well on this series. Probably going to be a series of videos, because I'll take my time and explain, and that will eat up more videotape. I'm going to get the Wixie out, turn it on here, and I'll set it on the back here. I've got a piece of steel, I don't know, 16-18 gauge, a little piece of scrap steel back there that I've stuck on the back with some tape. And that will hold the guide, or that little piece of steel will hold the angle calculator, angle guide, angle measurer, angleometer. And I'm going to zero it so that it says current position equals 0. And so now it's at 0. And let's see, the earth level shows 89.5 degrees. But the actual angle is showing at 0. So now when I loosen this and move it, it will show, because everything's square right now, it'll show when I move 2.9 degrees from its current position. And when I reach that, then I'm going to stop, because then I will have opened this up the proper amount to get the angle that I want. If that's not clear from my explanation, it should be clear here when I do it. Okay, so I'm going to slide this back. Oh, I'm going to give it a tiny tap. It just moved to 2.9. I want to make sure I get a solid 2.9 and not a 2.99. Get down close to 2.90. This is only a single digit reading on there, so if you go 2.99, it's only going to read 2.9, but you're going to be close to 3.0. So once you hit that 9, you've got hundredths of a degree to deal with, but I can't measure those using this. So as long as I get on the 2.9, I'll hold it there, and that's been working pretty good as far as getting accurate enough. Now I will grind the entire knife, both sides, at this setting. I don't, even if I stop in the middle, I won't change. If I stop, say I grind one side, and then I have something to do and I go away, I don't change the guide until I've ground the other side. And the reason is because what I just explained, even though I'm setting at 2.9, it could be at 2.99. And if I come back out and set up again at 2.9, it could be at 2.91, which, you know, is going to give slight variations between sides. So if I grind one at 2.99 and grind the other one at 2.91, there's almost an entire degree of difference in the setup that I'm unable to detect on my meter. And so that's why I'll grind everything at least grind the same knife on the same settings before I change it. Now, if I were to take it away and go do something and then come back and had to set it up again, this knife would already be finished and have its, it would be as close matched as I could get it. And then I could set up again. Now you're not going to notice a big variation if you go 2.99 on that knife and 2.191 on this knife, because these will both be at 2.91, those will both be at 2.99. Alright, all that baloney. Now, one of the things about the guide I wanted to showcase is that at this point it's all set up, and if I wanted to do something, suddenly I wanted to use the Platen for something, I can take the guide out and its settings don't change, and I can use the Platen for some work. It's still at 2.9 degrees. This is still set up square. As long as I don't bump it or drop it, it doesn't move. And then when I put it back in, the way these clamps are set up, so when I put it back in, as soon as I tighten it, these clamps bring it back into its original or in its previous position. So I can take that out, I'll pull that back out. You'll see in the process when I'm grinding, I'll pull that back, I'll just loosen it up like that, and I'll slide it back. I'll change the belt. Say I'll go from 120 to a 220. I'll put the new belt on, make sure it's running good, slide this back in to the position, close to the position, and then lock it down, and I'm set back up. So it's all that setup is preserved in the guide. And then as far as this part in and out, that doesn't affect either way. I can move this back and forth. I can take the guide in and out. It's moving along a straight line. It's not adjusting any angles or any rotating. It's just moving this direction in and out. And so that axis is not being disturbed or changed by the guide going in and out, or by this backing up forward and backwards. Alright, so that's kind of an explanation of how the guide works and how its relationship is with the machine. On my guide, I've only made 3 of these. I've sent one to the UK, one to Whitebone Knives, and I've kept one for myself where I've made a side adjustment. It creates an expensive guide to take 2 of them and put them together, but it is very handy in my opinion. Robert over at Whitebone Knives didn't feel it was as handy as the price, so that's one of the reasons I haven't made any more, is because it does add quite a bit to the cost. I do have some ideas in work that I'm going to try to manage this kind of an arrangement at a lower cost. That'll come out in the next few months or maybe early next year. This is a one-man operation, so thinking, designing, building, testing, all has to fit in and around my regular life, so things go slow. But I really like it. I can really, the other alternative to side shifting via this knob is side shift via loosening. The other alternative to side shifting via this knob is side shift via loosening the handle here and then bumping this one way or the other. And you don't get near as good or as small resolution as you can when you're bumping the handle as you can by adjusting this knob. Because the knob you can adjust in increments less than 1/1000ths. I've had a digital readout attached to this before. That's what this little arm was for. I've attached a digital readout to check it, and you can you can bump at several increments below 1/1000ths. So you can hit this several times, making adjustments, micro adjustments, before you actually add up to 1/1000ths. I can hit it, you know, about 3 times. I can make little adjustments before it equals 1/1000. So it's very good resolution on those, even though they look kind of primitive looking. They are really good for this application, in my opinion. What else? Some things about the machine. This has a ceramic platen on it. This is 1250 degree ceramic platen, 750C. It's 2 inches wide. I've got it at 8 inches long. These wear very good. I actually sell these on my website. These are stainless steel that I've ground to square. I have all the parts laser cut, then I'll TIG weld them together, or I'll weld them together, and then I grind them. Some details about the machine. This one, I just threw it together this afternoon. I'm going to clean this up for the rest of the videos. I'm using a linear actuator, and so this is an electric jack screw. There's the motor there. This is the screw here. There's gears across the back. When the motor turns the gears, it runs the jack screw, which raises it up and down. I'll give a demonstration. So I've got a little puck here with an up and down on it. I use that for the tension. So it's got a 2-inch travel, which is way more than enough. I'm running a 3500 RPM 3 horsepower motor. This is a K-back 29-1P variable frequency drive. Put a power switch on it. I put a forward and reverse on it for convenience. This is for convenience. Alright, on this side of the machine, I'm running this is a knife grinder part, 6-inch drive wheel with a 5/8 shaft. I've had good luck with these. I like them quite a bit. Actually, I've used about 6 of them so far, and they've all been very nice. Because I'm running this at, I set up the VFD at double speed, and then I custom tune it so that it runs the drive wheel at about 4,900 RPM. It's running about 4,900 RPM of the drive wheel. And because of this hole that they drill down through there to tighten up to apply a set screw to that key down there, there's quite a bit of material missing on this one side, and at 4,900 RPM you'll notice a vibration through the machine resulting from this. So what I do is I take lead shot number 7.5 from the shotgun that goes in a shotgun shell, those little things, and I tap the hole right there. And so once I get this in position, I'll tighten the set screw on that, and I add lead shot in there until I get the amount the balance level that I want, and then I add another set screw down on top of that holds the lead shot. So what we got is a set screw here that holds the wheel on, lead shot, and then another set screw that holds the lead shot in. And that balancing method has been very effective. It's been very nice. Alright, so a little bit about the machine frame. It's a 100% aluminum frame. It's welded. It's very lightweight. The frame and the motor with the drive wheel on it weighs less than 95 pounds. I can ship the whole thing set up like that for less than 150 pounds of weight. Or a part of my design strategy has been to minimize machining, and the aluminum allows me to do that. I can cut it on the table saw. I cut it on a chop saw using a non-ferrous metal blade. So I cut the extrusions to length. These are obviously extrusions. They weld very quickly. Very little drilling, very little machining. Looking right now, the only machined parts on here would be like the wheels at this point. This is extrusion, this is extrusion that I've cut. Inside there is extrusion. So hardware and the mounts back there, I bought those mounts for that linear actuator. So everything that I put on here has been extrusion or plate. So I just cut it like wood and weld it like metal. And that keeps the cost way down. And so one thing that nobody else is doing at this point is to use the extrusion as a clamp. Everybody else is using like a steel tubing, or they'll use an arrangement of plates to create tool slots, and then they take and use a jam bolt that goes in to the side and presses, and actually, those dig into the side of your toolbars. But if you've had experience with any machine that has those kind of steel parts on them, you know that there's slop inside there. And so the reason I say that is because that's the first machine that I built had the steel tubes. And so I had to actually, you can see that I like to be able to recreate accurately, and so it would be difficult on those because of all the slop that was in the tube with the tool arm. So I had to put in bolts this direction and bolts down to keep the tubes from rocking inside each other. And so that was one of the reasons that I had come up with this method. Once these clamp down, it clamps the entire length of the tube all the way around and holds it in place without marking it up. It doesn't slip, it doesn't wiggle, there's nothing, it doesn't move at all. And so I've got two of those arranged. This is a side configuration one, and then I've got one on the bottom arranged like that to keep the handles out of the way of the belt, and that holds that in. This is something that I'm actually just testing now. This is my first unit. This is the prototype for this tracking assembly, and what it's doing is it's pivoting the tracking wheel around a point that's right here. So there's an axis inside there that allows the tracking wheel to pivot around its center, centered here and centered there. So the tracking wheel will pivot without actually raising or lowering. And I've made a couple of videos in the last 2 weeks to kind of demonstrate that concept. It's been working out amazing. I'm really happy with the results so far. I'll give it a quick demonstration here. So that's it right there. You can spit the belt straight off if you want. There's enough motion in there. You can spit the belt off. It tracks it very good. Tracks it forward and reverse nicely. And the reason for that versus the ones that will have like a hinge up here and a little flap that the wheel's on, and then will tilt like that, and that actually will raise and lower the entire wheel, is because of the linear actuator. Because when it goes up, it's rigid, and so to tilt the wheel, the entire wheel off a pivot point up here, actually changes the belt tension. This thing, I can move the belt from full travel this direction to full travel this direction, and it doesn't change the belt tension. Keeps the same belt tension all the way across, so they're fully separated. Tracking adjustments don't affect the tension, and the tension adjustments have a much less effect on the tracking. Where before, when you'd have the wheel up in this position and you adjusted tracking, suddenly the belt would, when you adjust tension, suddenly the belt would slide to one side as the tension increased, and then you'd have to adjust your tracking again. I can adjust this belt across here, and then if I needed to make tension adjustments, I can adjust those, and it doesn't cause the belt to fly around. That's kind of where I'm at, and that's what I'm going to be using